Okay, how do we graph an inequality? This is an inequality. -4 is greater than or equal to x. What does this mean on a number line? Let's do 0, 1, 2, 3, -4. Okay, if we say that -4 is greater than or equal to x, that means that x can be -3 or x can be -2. I'm sorry, -5. If x is less than -4, -4 is greater than x, then that means that x's are going to be over here on this side. Okay, this side, right? Now, the question is, can x be -4? Yes, it can. And so we use a filled-in circle to remind us that we have an equal to right here. That means that x can be -4. Good. Sometimes we use a filled-in circle, and sometimes you'll see people use a bracket instead. Okay, so sometimes you might see people use a bracket instead of a filled-in circle, like this. All right, and how do we write this in interval notation? Is parentheses negative infinity. That means it never stops going to the left. Okay, never stops. And then -4 with a bracket to let us know it includes 4. Okay, great. Let's do this one over here. 0 is less than x. Okay, so we have 0, and 0 is less than x. So where is x then? X is going to be bigger than, right? So we're going to graph over here. We're going to shade over here. All right, and does this one include 0? There's no line underneath, so no, it doesn't include 0. So we use an open circle. Okay, an open circle to remind us that it doesn't include x, doesn't include 0. Okay, and sometimes you might see people using a parentheses instead of an open circle. All right, and in interval notation, we'd have an open parentheses, 0, meaning not including 0, comma, infinity, meaning that it never stops going right. All right, great. Okay, let's talk about solving these. Okay, solving inequalities is exactly the same as solving regular equalities with one exception, and that is when you multiply or divide by a negative number, things change. So let's look at an example real quick. If I say that 3 is less than 5, okay, and then I multiply on both sides by -2, okay, -2 times 3 is -6, -2 times 5 is -10. So what happens here? Is -6 less than -10? No, actually, -6 is greater than. So let's look at a graph real quick. We have 0, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, -6, 7, 8, 9, 10, -10. Okay, look how 0 is less than 5. It's to the left of 5, but -10 is to the left of -6. So -6 is greater than. So when we multiplied by a negative number, it didn't switch the absolute values, but it did switch the actual values. So instead of having a less than symbol, we had to switch it around. So we flipped this the other direction. All right. Let me erase this, so let's put that principle into practice. That's the only difference between solving equalities and inequalities. Okay, so let us do this one the normal way. We will divide both sides by 9, and if we're dividing by a positive number, nothing changes. Okay, so we get this, no problem. Over here, we're going to divide both sides by -2. But as soon as you divide by a negative number, you can no longer have your inequality facing the way it was. You have to flip it around, okay? And so then we get r is less than 6. All right, great. Let's look at this one. Similar to a normal equation, okay? Let's first distribute the negative, okay? Don't forget to distribute. negative 2x minus 1, and then we have greater than or equal to, distribute the 4x minus 4 minus 3x, okay? Then we'll add like terms, negative 2x negative 2x minus 16 is greater than or equal to, add like terms over here, x minus 4. Okay, let's add 2x to both sides. Negative 16 is greater than or equal to 2x minus, sorry, not 2x, 3x. 3x minus 4. Let's add 4 to both sides. So negative 12 is greater than or equal to 3x. And then divide both sides by 3. And we're dividing by a positive number, so we don't need to flip. So divide both sides by 3, we get negative 4 is greater than or equal to x. Okay, now, so how do we graph this? Just for remembering, negative 4, so this is, let's say 0 is right here, and then 1, 2, 3, negative 4 is right here. We want to say negative 4 is greater than or equal to x. I think this is the same one we already did. We will put a bracket or a filled-in circle at negative 4, and then graph that x is smaller than negative 4. Okay. In interval notation, again, we have this with a bracket right here. Okay, let's look at this one. This one we have two inequalities, okay, two of them, with our variable in the middle. Normally our goal is to get the variable on one side of the inequality and everything else on the other. In this case, it's our goal to get the variable in the middle with everything else on the two sides. So we want the variable by itself in the middle. Let's go ahead and add 1. And if we add 1 to get rid of this one, we have to add 1 everywhere. All right. So we'll add 1 everywhere. That way the 1's will cancel out. And so we have 3. Grab the wrong color there. 3 is less than or equal to 3x. Is less than or equal to 9. Okay, and if this was a negative 3 and we needed to divide by a negative number, you would need to flip both of these inequalities the opposite way. But it's not, it's a positive number, and so we're good. So let's divide everything by 3. We'll get 1 is less than or equal to x is less than or equal to 3. Okay, now let's graph this inequality. Okay, let's say this is 0. We have 1, 2, and 3. We say that x is in between. Notice that it's visually in between 1 and 3, and so that's how we'll graph it as well. And since it's equal to, we can put filled in circles or we can put brackets. Okay. And in interval notation, we would have from 1 to 3, including 1 and 3. That's why we use the brackets. All right, great.